Hello everybody. In this video we will discuss how to deprotonate an alcohol. So we have an alcohol, our favorite alcohol molecule, ethanol. So ethanol has an acidic proton. So if you want to deprotonate, what do we need? Remember our Gen Chem? If you want to deprotonate an acid, you need a base. So alcohol has a very weak acidic proton, so we need a very strong base. So in this case, we will be using a very strong base called sodium hydride. So sodium hydride is basically a sodium plus ion. So we got sodium plus ion. So we know metals are positive and H minus ions. So hydrogen has 2 electrons. That's why it has negative charge. So this is your base. So hydride ion is a very strong base. So what would happen is this hydride ion, the negative charge here, will abstract the proton, and the 2 electron that's present right in the middle is going to go towards the oxygens. So as a result, what would you be making? You will be making CH3, CH2, O negative. Like if you want to show all the electrons, you can. So basically oxygens will have 3 lone pairs, and as a result it will have that negative charge. And what would happen to the sodium? Well, sodium will become the counter ion. So every time you create something negative, it has to be balanced, right? So it's the counter ion, in this case will become sodium plus. And what would happens to hydrogen? Well, so if you noticed, the hydrogen had already 2 electrons. So that was the one that is blue. So this is the blue hydrogens, hydride ions, that has already 2 electrons. Now it abstracted one of the green hydrogens, which is right here. And they created this bond between H and H. So what is the bond? So when you have 2 electrons, that's a single bond, or that is our hydrogen. So this hydrogen gas right here is gonna leave the reactions. It's going to leave the reactions. That's why so you have an arrow pointing up. So this arrow pointing up tells us the hydrogen gas is eliminated from the reactions. So that's how you create, you deprotonate an alcohols. So you basically use a strong base. Now you can do this another way. You don't have to treat with sodium hydride. You could do this with a proper sodium metal, CH3, CH2, OH. Okay, I would show this. Plus, if you use normal metal, now what normal metal, a sodium metal will do is it will give 1 electron. So sodium here, it is in neutral state. So just remember this, sodium is neutral, but before sodium has in the positive state. So sodium has already lost the electron, but here sodium is pure metal. So what this will do is this would also do the same thing. So it will provide a electron to the hydrogens, CH3, CH2, O minus, and the counter ion would be sodium plus, because the sodium here gave away electron and becomes sodium plus. Who did it give away the electron? Well, it gave away the electron to hydrogens. So now hydrogen has 1 electrons. Now what happened when 2 hydrogens, when 2 of these comes together? So if 2 of the hydrogens comes together, they will become hydrogen gas. So in order to balance these equations, I'm gonna multiply 2 everywhere. All right, so now you can see 2 of the alcohol gave 2 hydrogen out. Those 2 hydrogen becomes hydrogen gas. So this hydrogen gas would go away. And then 2 of the sodium neutralize 2 of the equations here, 2 of the ethoxide ions right here. Because it's multiplied by 2, as a result, everything is double in this circle. And that's how you make an alkoxide or ethoxide ion from alcohol. All right, let's stop the video here.